Hello, good evening in New Zealand, Aotearoa, deaf community and all. It's a lovely Sunday evening and we're very keen to see people through Facebook and YouTube joining us this evening. I'm your host on behalf of Deafradio and Deaf Action New Zealand and our special guest, Dr. Pink. Thank you so very much for joining us this evening. Just for our audience, we explained to Dr. Pink yesterday the deaf community name sign by which she's known, and you're quite happy with that, aren't you? Fantastic. So, as you can see, everybody, we have two interpreters with us this evening. When Dr. Pink is speaking, Dan will be interpreting, and when I am signing, Tania, whose voice you're hearing now, will be voicing, but we know that this could be a bit distracting, so we'll have the video turned off. So this evening, we're going to be talking about the vaccine, and we'll be asking Dr. Pink all sorts of questions relevant to the topic. We know that the deaf community is very interested because of the number of submissions we received, questions asking what they wanted to know. So we have two parts this evening. The first will be a discussion with Dr. Pink. And after some time, around 8:45, that part will end. We'll be joined by Shannon and Leo from Wellington, who will talk about masks, the vaccine, and all sorts of administration questions. So we'll get on with it. I'm just wondering if there's any other housekeeping things that I need to add. But I think I asked you yesterday, Dr. Pink, do you know some sign language? A little, perhaps? Fantastic. That's so awesome. Well, that'll do just fine. Thank you. So, as I explained, we had our online rehearsal yesterday. We looked at the questions and we discussed how some of them were a little repetitive in theme. And so the recommendation was that we use visuals and a PowerPoint with animations to answer some of the questions initially. So yesterday, Dr. Pink presented the information in PowerPoint form, a 16-minute video in total, and we've had this video interpreted into NZSL 3, 6, and 7-minute segments, after which we will have a pause to ask questions relevant to each of those parts. So the idea being that we can incorporate the deaf community questions in amongst all of the videos that have been pre-recorded. We do welcome questions from the audience at any time, and I'm sure that you'll all be interested to know what kind of questions that they are. So I think that's enough housekeeping. Let's kick on and get into it. So let's go with the video.
Kia ora, everyone. Just a brief little talk from me about COVID-19 vaccines. So I want to start by talking just a little bit first about our immune system. And I can get the slides to move. So the best way to think about our immune system is a series of, I guess, military forces. And by that, I want you to think about how the military has got lots of different branches to it. So we have the Army and the Navy and the Air Force. And then with each of those different forces, we also have different types of soldiers, I guess. And so what I want you to think about is that each of these different types of soldiers represents the different types of cells we have in our bodies, and they all have very specific jobs. And then we can think of the Air Force and the Navy and the Army as being the types of soldiers that work in different environments. Okay, So a vaccine is basically a way of getting our soldiers, our forces in the right place when we need them. So when somebody gets infected with a bacterium or a virus, what we need to happen first is to signal that we need help, that we need these different soldiers and different forces to come in and do their job. And so this is just a little graph that shows you what that looks like when we are have an infection. So first of all, our body encounters this new microbe, and then those different soldiers get mobilized. And it takes a little bit of time for that to happen. So all I want you to see here is that we've got weeks after the first symptoms, and we've got these two lines, the orange line and the blue line, and they just represent the levels of different types of soldiers in our body. And they take time to come up. So we've got some that come quite quickly, but actually the ones that are the ones that hang around and are the most protective of our soldiers take a little bit of time to come. So what we do with a vaccine is it's like giving our armed forces a detailed dossier and maps of the, of the enemy's plans of attack, so that they are on standby and ready right when an attack happens. So all of this process is massively shortened. We have all of those soldiers right on hand when we need them, rather than waiting for the messenger to get to them to tell them that they're needed.
And here we are again. Thank you for the examples, especially how we could compare the virus and antibodies to the military. So the vaccine gives us immunity. So the question that we received is, if we already have a natural immune system, our body is a clever machine and can protect itself. So do we really need a vaccine? Wouldn't we rather leave it to the body's natural immunity system?
That's a great question. So the really important thing about our natural immune system is the fact that it takes some time to respond. And in that time, the virus is growing and infecting cells. And often the danger to our bodies comes from the growth of the virus. So it's actually our body responding to the virus that causes the damage. And so when we do this vaccination and we prepare our body in advance, it means we have a much faster response and much less opportunity for that damage to happen. So it's definitely safer to have a vaccine, but it's using the exact same process in our cells that you would have from a natural infection, just one that actually protects you rather than making, that lets you get, instead of getting sick, rather, you end up protected much quicker.
A faster response then. And so in terms of our natural immune system, does that change as we age? So if that was the case, wouldn't we want to immunize older people? What about children? Can you answer that, please?
So our immune response definitely changes as we age. So we know that babies don't have a great immune response at first, and that's often why they're protected by the antibodies from their mother. So from either through, if the mother has been vaccinated or had an infection during pregnancy and makes these soldiers, they can go through to the baby and protect them for those first few weeks of life until they are old enough to be vaccinated. And the same as when a mother is breastfeeding. So those protections can also go through her breast milk. And we know that then as people age, their immune response isn't so great. And one of the things we've seen with COVID-19 has been that older people are more vulnerable to a very serious infection than younger people. It was quite a mystery at first why little children weren't affected so badly by COVID-19. And that might just be because children get lots of coronaviruses, which are related to this one, but are like the common cold.
Thank you for that answer. A third question then, in terms of the vaccine, can it actually harm the immune system, the body's natural immune system?
We haven't seen any evidence of that, and we certainly haven't seen that from other vaccines. No.
Great. Thank you. Why don't we have a look at the second video about the vaccine and how it's manufactured? It's about 5 minutes long.
Okay, so there's lots of different ways that we can make a vaccine, and we have been doing this for a very long time. So the first way is that we can take the whole microbe and basically destroy it, so heat it up or inactivate it in some way, and then deliver that as that detailed dossier. The next way is that we can just use the bits that our cells recognize, so the very detailed parts of that dossier. In the case of the SARS-CoV-2 virus that is responsible for COVID-19, that's the spike proteins. And we can do this in one of two ways. We can either take those spike proteins and engineer them onto a harmless virus, or we can actually just deliver the spike proteins themselves in what's known as a protein vaccine. And then the last way is this new kind of way of developing a vaccine, which is basically just to take the recipe that tells our own bodies how to make the spike protein in the form of mRNA. So what I want you to see from this tracker is that since the start of the pandemic, we have had many different types of vaccines start the clinical trial process. So the clinical trials come in 3 phases, and the first phase is all about understanding safety, and then the second phase is starting to look at whether they're actually, how safe they are and whether they're starting to be effective, and then the phase 3 trials are basically how effective are they, do they work? And so what we can see from here is that there are many vaccines at different stages in this, but we've got 8 that have been approved for use in humans. So this has all happened very fast, and I know some people are a bit concerned about that. So normally it would take, we say, 5 to 10 years to get something from the lab side into people, but within this pandemic, it's really only taken just over, a year. And so what I want you to see from this is that under normal circumstances, each of these phases is carried out one after the other, usually with quite big gaps in between while people try to figure out how you're going to pay for the next stage. Sometimes it also takes quite a long time to do each phase because there might not be enough patients to enroll in those trials. And what I also want you to see is that at the end of that is when both the manufacturing happens, but also the looking at how giving the regulators all the information in order to decide whether they're going to license the particular vaccine. What's happened during the pandemic is each of those phases has been lined up so they can be done as quickly as possible, not one after the other, but sort of side by side. The manufacturing started at the very beginning, so lots of different vaccines went into manufacturing, a very risky thing because it wasn't clear that all of those that were being manufactured would be able to be used. But it meant that once there was good safety data and good data that they were effective, there were now vaccines that could actually be used more widely. And the other thing is that the regulators have been getting information on the safety and that efficacy, again, as the trials have gone along. So they've been able to evaluate it all the time rather than waiting for it all at the end. So that's how they've managed to do it so quickly. And I guess what it just highlights is actually how quickly this can be done. And that a lot of treatments that we've been waiting years for could have been done more quickly had there been the amount of money, I guess, that's been put into COVID-19 vaccines. Okay, so when New Zealand, at the beginning of the pandemic, the New Zealand government brought together a group of vaccine experts, immunologists, and they had a look at what vaccines were going into clinical trials, and then they made the decision to buy basically 4 of them. And this just shows that actually, so they were trying different types of vaccines. So we've got a protein vaccine and some that are these what are called viral vectors. So basically when you take the spike proteins and give them to another less, like a harmless virus, like a cold virus. And then the very small amount of money was put into this new mRNA vaccine because we didn't know whether that one would be effective or not. But the thing about the mRNA vaccines is they're much quicker to manufacture and develop compared to the other vaccines. So they were the first ones that went into clinical trials. And that meant when that data started to come out, we had good data about them first. But what we've also seen is that those vaccines have been very effective. So this is some of the data from the trials. What we can see from this graph is basically the difference in effectiveness of the different vaccines. So the Pfizer and Moderna are these mRNA ones, and the AstraZeneca and the Janssen are the ones that are looking at using the proteins on a different virus. And these mRNA vaccines are much more effective, certainly from this data. So that was why the government then decided to basically, buy this one, enough of this one for all of us.
And here we are again. It's really interesting in terms of the vaccine. It normally takes 5 to 10 years. And looking at the diagram that you showed us, this was generated quite quickly. And so that's a good thing, isn't it?
It's a good thing, but it shows you what happens when so much money is put into an area. So we had scientists all around the world stop what they were working on and start to work on COVID vaccines, and governments all around the world that put millions and millions of dollars into that development, helping to fund those trials.
And so in terms of COVID-19, we understand that that's from the coronavirus family. And so how long has coronavirus been around? And has the coronavirus 19 vaccine been created in direct response to that or to previous coronaviruses?
That's a great question. So there are lots of coronaviruses, and most of them are harmless cold viruses. But there are 2 others that are very serious in humans. One is called Sars and the other called MERS. And so SARS emerged about 2002, so 20 years ago. And research has been going on into that virus ever since. So as well as the way to make these mRNA vaccines. So there's been about 20 or 30 years of research in labs to understand coronaviruses, but also to develop this new technology. And so when this pandemic started, they were basically able to draw on all that knowledge to get these new vaccines made so quickly.
Thank you for that answer. We know here in New Zealand that we're using the Pfizer vaccine. And in your opinion, what are the pros and cons of that vaccine as compared with others? Is it safe? Could you tell us what your own personal opinion is on this?
The data shows it's very safe. I guess people were a bit scared because it's new technology. But the important thing is that it uses a process that happens in our cells every day. So it's getting us to make the vaccine, which is very, very clever.
There was a little frozen part. Dan, could you repeat your last sentence, please?
The advantage, though, the advantage to this type of vaccine is it's very quick to make and very quick to change if needed. And that is going to be important as the pandemic carries on because of the new variants.
Thank you. I think that's a perfect time to take a look at our third video, because that talks about the vaccine itself and what is actually on the inside. So let's take a look at that video.
Okay, so what is this Pfizer vaccine? So the list of ingredients are basically as I said, that recipe for how to make a spike protein. So this is in the form of what we call mRNA. The next thing, so this is very fragile, this mRNA. It breaks up very, very easily. And so in order to stop it from breaking up, we put it inside of a lipid nanoparticle coat. So all this means is we're basically wrapping it in fat. There's lots of complicated names for these different types of fats, but basically they're just little droplets of fat. And the nanoparticle means really, really tiny droplets of fat. So we're trying to make those droplets as small as possible, because inside each droplet we can put a little bit of this instruction or this recipe. And so the smaller the dots, the more bits of recipe that we can have in our injection. The other thing is that is put in this vaccine are different kinds of salts, and this is just to make sure that it's a similar pH to that of human cells, so it doesn't make your cells respond badly in any way. And then because that recipe is so fragile, we have to keep it at low temperatures. And so in order to protect everything at low temperatures, we give everything a bit of sugar. So sucrose is the other ingredient. So that's it. Very few ingredients at all. Some people will have had these ingredients before. So this tiny fatty coat is a really good way of delivering lots of other medicines. And so people will have had that in other medicines that they've had. And that's why some people have had an allergic reaction to the vaccine, because they've already had this fatty coat, and so they've mounted an immune response to that. And that's why people stay for 20 to 30 minutes afterwards just to check whether they are not going to have that reaction. Because if you have it, if you're at the vaccine center, you can then be looked after. So the way this works is taking advantage of a way that our cells work. So what we do is we give this recipe to our cells. We've got little machines inside of them called ribosomes, and they basically then turn that recipe into the spike protein of the virus. The cell basically shows that to the rest of our immune response, so to our little army of cells, and then from that we make antibodies, which are the protective cells from our immune response. So people have asked a little bit about side effects. So we've got information on side effects and things. What we see is that often the side effects are a little bit worse after the second injection. So there are 2 doses of this vaccine. The first sort of kickstarts your immune response, basically is the first call to that army, and then the second one is a booster that basically makes sure that your immune response has heard the call, make sure that your army is on the job. So we see things like pain at the injection site. That's fairly obvious because you've just had an injection. But some people will feel things like being tired, having a headache, having muscle pain and chills. These are really common things that are the way that your immune response works. So this is just showing that it's basically doing its job. One of the things people have been asking about, though, is how do we know these vaccines are safe? So obviously we've run them through those initial trials, but we are basically following them long term. And I just wanted to tell you about this project, which is the Global Vaccine Data Network. So this is a project that is following 290 million people for 3 years in the first instance after they've been vaccinated. They are from all around the world, 6 continents, 17 countries. And the really amazing thing is that this is all being coordinated out of New Zealand. So Dr. Helen Patusis-Harris has got the contract to do this. She is an expert in studying vaccine safety. She's done this in our country for other vaccines. And so she's coordinating this. And they use this enormous number of people who've been vaccinated using big data to understand what kind of side effects there are, really subtle things, really small things, really rare things. You need very large numbers of people to monitor that. So that's what they're monitoring. That's how we do it. We do it by getting people to report symptoms, by getting people to, so they can do that directly on various websites, and then they all get investigated. We also do that by, getting people to report them to their health providers, and then all those get investigated. And one of the things that I will say is that we've seen lots of what we call misinformation circulating around, saying that we've had very few deaths from the virus in New Zealand, which is true because of our elimination strategy, but that we've had more deaths from the vaccine. And this is just simply not true. When we are delivering a vaccine to millions of people like we are doing in New Zealand right now, there will always be some people who will die anyway. So this is especially true when we started vaccinating the very, very elderly. And so every time, those deaths will be recorded, and then they will be investigated. Were they just, they're just something that happened at the same time, or were they actually related to the vaccine? And so what you're hearing is probably things where people are just looking at 2 things that have happened coincidentally rather than actually being related to the vaccination. One of the things that is popping up as a concern is heart inflammation in younger people, 16 to 24-year-olds, particularly after the second shot, and particularly in young men. But these are still very rare and very treatable. And they are a thing that happens after COVID anyway. So everything we're seeing at the moment, if there are any things that happen after the vaccine, they are things that you are definitely more at risk from having COVID-19, and your chance of getting it from COVID-19 are much, much higher than your chances of getting them from the vaccine. And the really important thing to remember about vaccines is that, they do a really great job of protecting you as individuals. So we know that the data is really clear that people who are vaccinated are much less likely to die or get a serious infection. But they're also really good at protecting each other. So while we know that the vaccines do not prevent all transmission, they definitely look like people are shedding less virus. So we will definitely see less people get infected the more of us that are vaccinated. Thank you.
And here we are again. I've been taking notes furiously, looking away from the screen, and I'm sure that the questions are flowing into our admin team as well. So in terms of the Pfizer vaccine, you've told us about the recipe. It has about 4 main components. There are the fats, which contain the vaccine, and other things like salt and sugar. It sounds really tasty, actually. But I guess the first component is the part that is the special part of it, isn't it? It's the mRNA component. So the spikes that are on the actual coronavirus cell, it's passed on to the body's immune system. Am I getting that right? Could you explain us a little bit more about the vaccine, please?
So to explain the vaccine, I need to explain how our cells work. So you know how we have DNA? Well, that DNA is sat inside of our nucleus and it can't leave our nucleus. So if we want to make a protein, what our cell does is it turns the DNA message into a photocopy, and that we call the mRNA. And that mRNA can leave the nucleus and go into the inside of the cell. And then inside the cell, we have these little machines that read that photocopy and make whatever protein our cell needs to make. So that happens in every cell of our body every single day. So what we're doing with this vaccine is it's like giving the cell the photocopy. So we are just giving our cell that bit of information, how to make the spike protein from the virus, and our little machines inside the cell do that. This is one reason that we know, so because it's this mRNA, it can't enter our nucleus, so it can't interfere with our DNA. It just stays in the cell. And as I said, it's very fragile. So because it's so fragile, it will end up being broken up really quickly. So it doesn't stay in our bodies very long. It just long enough to make some of these spike proteins to show to our soldiers, and then it gets destroyed.
That gives us a good idea now of how the immune body responds through the vaccine. So another question then, in terms of the vaccine, it doesn't prevent us from getting COVID-19, does it? We still can pass it on if we have the virus, even if we're vaccinated, is that right?
That's one of the really
I guess it's a concern for some people. I'm so sorry to interrupt you again, but in terms of the Pfizer vaccine, we know that there have been messages about the efficacy of the Pfizer vaccines, but now with the Delta variant, we know that there's a risk of a lessened efficacy with the Pfizer vaccine. Can you tell us more?
Okay, lots of questions there. Let's start with the transmission one, or about catching COVID if you're vaccinated. So, you know how I talked about the different parts of our arm or our forces, how we've got like the Army and the Navy and the Air Force. So the really important thing is that our immune system has different parts that work in different bits of our body. And when we get this COVID infection, it starts in our nose and our throat, and then it moves to our lungs. And so the bits of our body, our protective soldiers in our nose and throat, are different to the ones in our lungs and in our blood. And our vaccine is an intramuscular, so it goes in the arm, and that generates these soldiers that work really well in the lungs and in the blood, but not so well in the nose. So what that means that when we get that first infection, so we can, even if we've been vaccinated, we don't have the right cells in our nose. So we start the infection, and then the cells in our lungs and our blood get to work. So they still do that faster than if we hadn't been vaccinated. What it means, though, is that it's likely that maybe a vaccine up the nose instead of an injection might work better. And those are currently in clinical trials. So it may be the next generation of vaccines might be up our noses instead. And if they were, then we would hope they would do a better job of stopping us getting infected at all or transmitting the virus to somebody else.
And so if we go back to the question about the Pfizer vaccine then, the efficacy was said to be 95% or thereabouts, but with the new Delta variant, is that lessened?
So it still seems to work really well against Delta. We don't know how it will work against Delta if Delta carries on evolving. So that's something that people are looking at. But the other thing about our immune response is how long our soldiers hang around for. And so that's the thing that we might see change. So we are worried that those cells won't stay for years and years, that they might only stay for a few months or a year. And that's one reason we might need a booster, is just to bring those cells back. And what we see with other vaccines actually is that after that booster, you might need a booster after a year or two, and then your immune response lasts for much, much longer, many years. So that might be the case with the Pfizer, but we just don't know yet. I think a good example is tetanus, where you know how we have a tetanus injection every 10 years. That's the same vaccine. It's just boosting your response as your soldiers disappear.
That leads me to a question then. Will the Pfizer vaccine improve in the future? Will a future vaccine be better than the one we've got now? And should we wait for that?
Good question. They will be looking at how the virus changes, because what we need is to recognize the spike protein. And so if there are changes in the spike protein, then we need to make sure that the vaccine makes us make cells that recognize that. So that's the thing that is being watched by the scientists. There's another vaccine at the moment that we're still waiting for all the data from, which is one of those protein vaccines. Now, these protein vaccines are ones that are very well understood, and most of the children's vaccines are these protein vaccines. So it may well be that our children end up getting that instead, if the data from that looks really good. Or maybe even that in a year or so, we will get boosters from that one. The important thing is that all of these vaccines are being trialed, and I'm sure that New Zealand will be making the decision based on which look most effective, but also how the virus has changed by then, and what looks like it would be most protective against it. Unfortunately, that's sort of one of the advantages of our approach, is that we've been able to watch what happens in other countries and really learn by that information, really, while being relatively protected here. It's like everyone else is the guinea pigs, which is kind of good for us, but quite sad for everybody else, really.
Dan, you're a bit glitchy on your side, but this is one of the things about the live stream, isn't it? We have technical issues, and so it does happen from time to time, but we're just going to crack on. Another question that has come to us is about that Pfizer vaccine. You had said that globally that there is the Global Vaccine Data Network, isn't there? And 290 people around the world are being monitored. So what the question is do we keep that information, and are those findings available just to the general public?
Another great question. So the findings will be published, I guess, by the scientists. I don't know how much is being made public, but I do know somebody who's involved in that. So I will ask them that question about how people are enrolled and what they will do about making the data more available. because that's a great question. And one of the things we have seen during the pandemic has been scientists being much more open about their data. So normally, we have to wait until they write their publications and, to publish in a scientific journal. And that can often take a long time. But during the pandemic, they've been much more open and sharing with each other much more and with the public much more, because people have needed those answers so quickly. So I will ask Helen, who is in charge of that, what's happening with that data.
Oh, thank you. Another question that we have been asked in terms of the vaccine. We know that there are side effects, which you spoke of in your presentation. And so are those side effects, dangerous? If we have a slight snotty nose or something, is that something that we should report back to our GP? What should we do?
So the normal side effects of having a very mild fever or having muscle aches and things, you don't really need to report those. We know that lots of people will have those because that is actually your immune response doing its job. That's exactly how it makes us feel when it's working well. Which is also not to say that if you don't have any of those symptoms, you should worry that your body isn't doing its job, because it will be doing its job. It's more the things that are a little bit unusual or last longer than they should. So the best thing to do is to report those kinds of things, because those are the things that they are looking for. Like has been seen with these heart effects in the young men. So it's those kinds of things that we need to know about, rather than whether somebody has a bit of a temperature or the chills, really. But if you are worried, you can just report them to your GP and they will let you know, whether it's worth reporting further.
Okay, then. One person from the deaf community has asked us about the vaccine. And we know how good it is already that New Zealand is protecting us through the border closures. And last year, we only experienced 26 deaths in New Zealand, which on a global scale is quite amazing. But for the number of people who have died from the vaccine, the person who is asking this question said that there were as many as 100 deaths from the vaccine. What's your answer to that?
The answer is no, there weren't. So we know with this reporting that they will report a death if it happened close to when someone was vaccinated. We've seen overseas as well that there are places where people can report all deaths, and there are things like people dying in car accidents, things that are completely unrelated, we know are unrelated to vaccination. The deaths we've had in New Zealand, because we started with the very elderly, there were people who were being vaccinated in rest homes who probably died of, as a result, not of the vaccine at all, but because of their age. So people in their 80s and 90s. And that the way we look at this is to look at what would be the number of people dying who weren't vaccinated normally, and then comparing that with the numbers who are dying after vaccination. And those rates are not different. The other thing to remember is that there have been more than 4 billion doses of vaccines given to people around the world. And the deaths we are seeing are in people who have been mostly unvaccinated, and they are because of COVID-19.
Just double checking there, Dan, 4 billion?
4 billion, yes.
Okay, then. Another question that I'd like to ask on behalf of a viewer. What would you like to say to any members of our deaf community who don't believe in the vaccine, that they don't believe in the safety? What would you have to say directly to those people?
So one of the things that we are seeing is lots of really bad and fake information being spread by people who are trying to frighten people. And so they're using vaccination as one of those things. The data is really clear that the vaccines are safe and effective, and they are so much safer than getting COVID-19. We can see that from the number of people who are dying. You know, you are much more likely to have a severe infection or to die if you are not vaccinated. There's a really interesting study that looked at this fake information about vaccination and found that they could I think it was maybe 2/3 or 3/4 could be traced back to just 12 accounts in the USA. And so these people are creating information, fake information, because they're trying to make money. So they are selling books and webinars and fake treatments, millions and millions of dollars worth. And unfortunately, people are seeing that information from overseas and then repackaging it and kind of sending it to people all over the world. So here in New Zealand, we have people who are reading that information and then repackaging it so it appeals to people in New Zealand. And the problem is, so people are making that fake information to make money. And then there are other people who are spreading that fake information because they are trying to push their own agenda. And it's really sad that that is causing people to die. And it's, you know, I understand how people will be frightened by this new technology and all these things, but there is no global conspiracy, you know, to harm people, except by the people who are trying to convince people not to get vaccinated, because we know that will cause great harm if those people get COVID-19.
And a related question then. Some people out there believe that the coronavirus is a human created virus and that the investors and vaccine developers are the ones behind it. What would you say to those people?
So we have been expecting something like this to happen. Microbiologists have been expecting something like this to happen because we know there are probably billions of unknown viruses in other animals. And so climate change and the way we live our lives means it's much more likely for humans to be getting closer to other wild animals' territories. So, and our food animals as well. And so every day there's probably the opportunity for a virus to jump from one animal to humans or to our our farm animals, pigs and things like that. And so this has been happening all the time, and it was only a matter of time before it ended up being, a really dangerous virus. So we know these coronaviruses are everywhere. They're in fish, they're in bats, they're in all sorts of things. We call these spillover events, and they're probably happening all the time, but almost all the time nothing happens. Maybe one person might get something and then it will disappear. So we saw this happen with SARS. So the first relative of this, of COVID-19, that happened. It came from bats. But because people with SARS had a really high fever early in infection, they were able to isolate those people and stop human-to-human transmission. And that's how we stopped SARS 20 years ago. So it's just something that's happened. We've kind of been expecting it to happen, but hoped it wouldn't happen. And unfortunately, with COVID-19, it's the time it's happened. I think one thing to think about is with every infectious disease, it's like having a handful of dice and you're going to throw that dice and get different numbers. And so every dice represents a different thing to do with the organism. So is it a virus or bacteria? How does it spread? What effect does it have? Where did it arise in the world and when? And with COVID-19, it's like we've thrown almost the worst handful of dice, because we have a virus that spreads between people before they know they're sick, and has symptoms that are very much like lots of other things, like just a cold. And it also emerged in a part of the world that has lots of people, and at a time of the year when those people were moving around. So it had left China before we really even realized it had. And unfortunately, it's been very hard to stop human-to-human transmission, because it just looks like cold or looks like the flu. And so it's been really difficult to control, unlike SARS, which was much easier. So it was one of these things that was bound to happen at some point, and unfortunately has happened. And it's because as globally around the world, we haven't dealt with it properly. If every country had decided to do elimination, we probably would have been able to stop it a year ago.
I'm so sorry. Dan, you're glitching again. Could you go back a couple of sentences, please? I'm so sorry. Where
did you get to?
Up to? Yeah, just that last sentence, please, if you wouldn't mind. Yes, it was just a little glitchy. Well, perhaps we should just move on. We do have a lot of questions to get through, and one of those is talking about the term herd immunity. And so as a group, we are building that up. Can you talk to us about whether herd immunity is achievable in New Zealand and around the world? What's your perspective on that?
That's a great question. So herd immunity is about having enough people protected by vaccination that we can protect those who can't be vaccinated. And it's a number that differs depending on how infectious a disease is. So for some viruses or bacteria, herd immunity might only be 70% of people, but the more infectious something is, the more people need to be vaccinated. And for this one and Delta, it looks like it's very, very high indeed. So maybe up more like the 90-odd%. So it's going to be very hard globally to do that. I would say impossible, because there are countries that don't have access to vaccines yet, and are probably not going to get access to vaccines for many years to come. And the problem in those places that don't have access to vaccines is the virus will continue to evolve, and it might evolve to so that our current antibodies don't protect us, in which case we will need another vaccine, a new type of booster to protect us against that new one. The other thing we have to remember at the moment is that the vaccines are not approved for under 12s. So we cannot get to that 90-odd% because our under 12s are not protected yet. And that's because we don't have the data on the vaccine safety for them yet, because the trials are still going on for them, for younger children.
And so in terms of that Delta variant, it sounds terribly dangerous. That leads us into this next question about safety. If we are wearing masks and we are just buying one, is it going to protect us from Delta? Do we need to add more layers to that? Or what should we do?
That's a good question. And the CDC in the USA is recommending that people double mask. So if you, we know that N95s are a much more protective kind of mask, but they're not really easily available to most people. And they're much more for people who are actually interacting with someone who is infected. So they're for use by our people in MIQ, for our healthcare workers. We have to remember that with us going for elimination, we don't want this virus in our community. And that's why we are doing level 4 right now. But it's quite different in other countries that are not doing elimination, where there are lots of people, infected people, just walking around every day. We are all at home so that we don't have lots of people, infected people walking around. So we know the masks are not 100% effective because they're not the right kinds of masks, but they will protect a little bit. And they're more about protecting, they're more about stopping if you have COVID-19, it's about stopping you putting too much of that virus in the air before you realize that you're infected and you've gone to get tested. So you can double mask, but at the moment we are just trying to get back to zero COVID so we don't have to wear masks at all.
That leads me on to another question. There is a concern about the second shot and how the recommendation has been extended from 3 weeks to 8 weeks. What's the explanation for that? The information has changed from the first time we started hearing about the Pfizer virus. What are your thoughts on that?
So the 3 weeks was the shortest amount of time that it made sense to put between those two vaccine doses, while the trials were carrying out. So at the beginning of the pandemic, we wanted to find out as quickly as possible, were the vaccines safe and effective? And because we understand how our immune system works, that 3 weeks was the shortest amount of time that you could put between the two doses. And so that's what was done in the trials, and that's what the vaccine was first approved for. But in the UK, they decided, because they were having a huge outbreak of the Alpha variant, they decided they would rather have more people have at least one dose, so they had some protection, rather than, and so they changed the length of time and made it more like 8 to 12 weeks before people had their second dose. And what we found from that is that people's antibodies, their armies, seem to hang around for a bit longer. So it's not about having a better response, but maybe one that lasts longer. And so that's why the recommendation has been now to change it and make it a bit longer. So if we think back to our childhood vaccines, we often leave these longer gaps between them, usually 6 weeks, sometimes a few months, depending on what the vaccine is. So that's perfectly natural. But because of the pandemic happening, that's why this 3 weeks gap was given at first. The really important thing, I guess, is for somebody who is really vulnerable to a severe infection, it is better to be fully vaccinated. And so in countries, in countries that have got widespread transmission, that's why it's good for people to have both doses. But for New Zealand, it was fine for us to wait because of our elimination strategy. And so I think that's why they've also said it's fine now for us to extend it out. Again, it's another one of those things about us being in a position where we can watch from what other people are doing and see what works best.
We are so fortunate here, aren't we? And I guess that brings us to a related question. We know that people are being vaccinated here in New Zealand and that we still can contract the virus and we still can pass it on, can't we? So what's your recommendation on the new normal and what behaviour we should be exhibiting on an everyday basis to protect not just ourselves but others in the community? What's that going to look like?
I think it has to include scanning and keeping track of where we've been. Because as we're finding out in this outbreak, you know, when there is an outbreak, people will start scanning, but we need to know where people were 2 weeks ago. And we've seen that from the contact tracers, is that they're finding, you know, I think they said something like 30% of people have been using the app, but they've had to contact thousands and thousands of people you know, who haven't been using the app, and that slows contact tracing down. So with a virus that moves as fast as Delta does, because it is that much more infectious, the quicker contact tracers can get in touch with people, the better. And that's what the app is really good for. It's good not just for us knowing where we are and who we've been with, but for them also to contact us so we can get an alert to say, you know, you were at a place and were exposed. So that's the thing that I hope everybody really starts to do well all the time. It needs to be just second nature, like washing your hands after you've been to toilet or something. The other really important thing is going to be staying home when sick and getting tested. Because, you know, the reason we picked up this outbreak was because that first person got tested when they felt sick. But they weren't the first person to get Delta in the community. So there have been other people who have got sick and they haven't got tested. And it's hard, right? Because you have to take time off work and you've got to go and let somebody stick a swab up your nose. But that's the thing that tells us whether Delta has got through. And so that's the thing that we need to be doing.
Oh, I've just got a few remaining questions before we wrap up for this evening. I don't know where the time's gone. It's just gone so quickly. We're having so much fun. But then my next question is from somebody who would like to know, in terms of the vaccine and having been vaccinated, is the New Zealand government going to establish some kind of digital COVID-19 certification? Are we going to need to carry such certification if we sometime travel overseas, and do we need one?
Another great question. So it's really clear overseas that and here in New Zealand, I guess, that people are going to have to be able to show proof of vaccination for some things. So we're seeing in some countries that you can't go into bars or into the gym unless you can show proof of vaccination. And this is going to be tricky because it's also something that can be faked. So I don't know what New Zealand government is doing, but there are different groups that are working on this. What I hope is we end up with something that works in multiple countries. So if we think about our COVID Tracer app, that's something that is a technology that lots of different countries are using. And it means that they're compatible between some countries. Whereas unfortunately for us, and we've gone with a system that is being used by multiple countries. Unfortunately for us, Australia went with a different system. And so that meant that our contact tracing apps weren't compatible. So I would hate that to happen with the vaccination things. That's
typical.
Yeah, but it's going to need to be something that can be verified. And, you know, there might be differences depending on what vaccine you've had as well, because we know that some are more effective than others. So this is definitely going to be a thing in order to travel in the future. But we have to remember that it's been like that for other diseases in the past. So there are some places that you couldn't go without being vaccinated before. So this is not new, but it obviously feels quite new, I guess, because most of us have not really had to, you know, we haven't been this limited in terms of traveling because of an infection before.
Mm. Thank you again. I'm just looking at my list of questions. One that we've received is from somebody who does want to have the vaccination, but they have heard that it may affect their ability to have children in the future. What are your thoughts and comments on that?
Another great question. So there is no data suggesting that at all. And it's not really, there's, again, knowing what we know about how the vaccine works, it's not really possible. But what I can tell you we know so far is there's been a few studies done looking at couples who've been undergoing IVF, and there has been no difference between the numbers of babies or the pregnancies between vaccinated couples and unvaccinated couples. There's been some studies done looking at sperm counts between vaccinated and unvaccinated men, and that's been no different. So that's not something that we expect. But what I can tell you we are starting to see some studies of is of things happening to mostly men after getting COVID. So things like erectile dysfunction, premature ejaculation, or not being able to ejaculate. So it may well, so COVID-19 itself may well affect fertility, at least in men.
Well, I've got another two questions before we wrap up. But the Prime Minister has said that in terms of border protection, we are going to be quarantining people from high risk countries for some time. Can you foresee how long that will be? Could it be 1 or 2 years? And will we still need to continue on with that? What are your thoughts?
My thoughts are, until all our children are protected and all of us, as many of us are vaccinated, that is something we're going to have to do, especially because the vaccines can't prevent transmission. So that might all change if we get a vaccine in the next year or so that can prevent transmission. That would mean then that somebody who was vaccinated was much less likely to have disease. But the thing we have to remember is that there is going to continue to be widespread transmission because many countries are not trying to stop the virus, right? So it does look like this is here for a long time. And we have to remember that, you know, at the moment, many of us, and certainly our children, are not protected. And what we're seeing in countries now like the USA is that their pediatric intensive care units are starting to fill up with children. And we know in New Zealand that we have got high rates of obesity and diabetes in many children. And so our children would likely be quite badly affected by COVID-19. I think we'll need to see what happens in the next year or so with the vaccines being approved for children, and whether that helps drop infections in other countries that are vaccinating adults really highly, but not children yet.
Well, I have to say, thank you so very much. We are out of time, but I wonder if we could ask one more question about the Delta variant. We know that that's airborne, isn't it? And we know that other variants are surface transferable. So if we see someone who's visited a supermarket and they've had the virus, it's been decleaned, will that be as effective if it's an airborne virus as it would have been for the surface-borne virus?
So it's always been an airborne virus, but we didn't understand that at the beginning, and we thought it was surface transmission. And this is partly back to actually really old studies about understanding aerosols and airborne and surface droplets and things. So what we know now is that it's always been airborne, that surfaces are probably very low risk, but probably not zero risk. So it's hard to say to somebody, just ignore all the cleaning, because that might be a way that you could get it. But we know that airborne is the main way. So it is by breathing in, contaminated air. And that's why the masks are quite important, that, when you, if you have the virus and don't realize it, that will at least reduce some of the infection. What makes Delta so much more infectious is that people are shedding so much more virus. So in the tests that have been done with the earlier variants of the virus, comparing that with Delta, people who test positive with Delta now have got about 1,000 times higher viral load in those tests. So that suggests that they are shedding 1,000 times more virus, and people are breathing that in. Yeah, it's a big number. And so before, we would maybe only see one person in a family. If somebody got it, maybe only one other person in the house would get it. But now we see everybody get it. And so one of the big things moving forward actually is how important ventilation is. So I think cleaning is still important, but more important is having windows open, having ventilation systems that will actually help change that, get rid of any air that might have virus in it.
Wow, I am just so thankful for your amazing answers. We've managed to get through most of the ones that we've received, but thank you so much for your time and your expertise. We do thank you on behalf of the New Zealand deaf community. Thank you. Thank you so much.
It's been such a privilege. And thank you for having me.
Great. Thank you. Thank you, Dr. Pink. So we're going to have another couple of guests who are going to be speaking to us. So we will say thank you to Dr. Pink and to our interpreters now.